Today we will practice sketching graphs from descriptions. Some of these graphs will be lines, but a lot of them will not be lines. They'll kind of go up and down, be flat. They're going to look like all sorts of different things. So it's kind of a little bit more fun than just lines. We're going to look at some graphs that have already been drawn for us and figure out why they are the way they are. In our first example, Mikey started out with $14 and spent $2 every day. So if you look at this, the starting point is always the y-axis, the y-intercept, So this $14, that tells me that on day 0, he had $14. I think that makes sense to me. Then he spent $2 every day. So if you look at this, I think this bottom axis is days. So then on day 1, he had spent $2. So now he has 14 minus 2, he has $12. And then 2 days later, he has 14 minus 4 because he spent $2 for 2 days, and then so on and so forth. So if you look at that $2 per day, that's the slope. That's how much it's going every y per x. So remember, we've already learned that any time you have a per, that is a rate of change. Okay, and then this graph will also help you find out when he ran out of money. He had $0 at 7 days. So sad for him. After a week, he is out of money. Poor chap. If I were British, that would have made sense. Let's go over here and try one that's just a little bit more complicated. Mikey started out with $14 and spent $2 every day for 5 days. Then on the 9th day, Mikey started saving $1 per day. So I'm going to talk about each of these questions, but I want to make sure that we have some time to sketch our graphs. So let's just observe what's happening here. He started out with $14, just the same, right? And then $2 every day, that's our rate of change. So that tells me that this has a slope of, negative 2. So it's going down 2 and then over 1, and it does that until day 5. Woohoo! Then on the 9th day, Mikey started saving $1 per day. So it doesn't really tell us what happened between day 5 and day 9. What I assume is that he didn't do anything with his money, and our graph kind of shows that. His money stayed at $4. Then on day 9, he started saving $1 per day. So you can look on day 10. That means if he saved $1 per day, then on day 10, he has $5 now, $1 more, $1 more. So that $1 per day shows us a slope, a change in y over change in x of positive 1, because that's what that per tells us. So this is super important. A lot of students, when they graph these graphs, they'll be like, oh, the money went down, so they'll draw a line like this. Now what that means is that on that one day, without moving, without time going at all, you simultaneously had $14, $13, $12, $11, $10, $9, $8, $7, $6, $5, $4. So if your money is going down, you got to account for the passage of time and say, okay, if it's going down, then a little bit of time passes. And if it's going down really fast, then it's really steep. And if it's going down much slower, then it's going to be pretty close to flat. So hopefully that helps us out. Now let's go ahead and graph our own graph. What would the graph look like if Mikey started out with $10, didn't save or spend for 4 days, spent $1 per day for 3 days, saved $2 per day for 4 days, and then didn't spend or save for the rest of the time? I don't know. Apparently Mikey he has the ability to not save or spend any money forever. Well, maybe this is just counting out the 16 days we have. So what would the graph look like if he started? Let's just start out with the first sentence, the first little blip, and just graph that, and then we'll move to the next part. So if Mikey started out with $10, I'm going to put, it already has dollars and days over here on my graph. Oh, excuse me. Let's go over here. It already has dollars and days, so I'm just going to say his starting point, start the stopwatch, it's going to be 0, 10, this is my dollars, and this is my days. Oh, that red is going to make me feel like my eyes are bleeding. Hang on. There we go. Okay, let's move to the next part. Didn't spend or save for 4 days. So that means that he still has $10 in his bank account for all 4 of those days. So I'm just going to, if it helps you out, draw specific points. But we're just, remember, no change in his money is a flat line. Then spent $1 per day for 3 days. So he spent. If he spent money, it's going down in his bank account. So I'm going to spend $1 per day for 3 days. Let's make sure my numbers make sense. So from 4 to 7, yeah, that's 3 days. Okay, so we did that. We did this part, we did this part, we did this part. Okay, next. Saved $2 per day for 4 days after that. So $2, if he saved money, his money in his bank account is going up. And then it's for each of 4 days. So from day 7 and $7, he saved $2 more. Then he saved $2 more. And for how many days? 4 days? Okay. So days 7 to 11, he saved $2 per day. And look at that. That's our slope of 2 right there. Okay, I did that one. And then didn't spend or save for the rest of the time. So no change in his money means it's going to be flat. Okay, so there's our graph. Now we're going to attempt to do this without any little dots on our graph because actually the standard for 8th grade is that you can sketch a graph. So if it's close enough, it's close enough. But you should also be able to approximate without necessarily finding exactly where the lines intersect. So I'm going to do A with you because now we're talking about Thomas and how far away he is from school. So our x-axis has minutes and our y-axis has distance to school in blocks. And Thomas lives 12 blocks from the school. So in the first scenario, Thomas stayed home and watched YouTube videos. So he's 12 blocks from the school. And he stayed 12 blocks from the school. He stayed home. So no change means a flat line. I don't know how I got my app to make that line so pretty, but it is beautiful. Okay, so now I want you to try B through D on your own. Try and graph those yourself, and then you're going to check your answers with me in just a minute. So pause your video, try B, C, and D. Remember to work through each part, just a part at a time, and then see what it looks like. All right, so I'm going to show you what I get for B. So he was at home. He was 12 blocks from the school. He left home and walked to school. And I'm going to say that these minutes represent since he left home. He started, if we were to start our stopwatch, the point that makes the most sense is when he leaves home. So we're going to say at 0, that's when he left home. And he walked to school at a rate of 1 block per minute. So after 1 minute, he is now 11 blocks from the school because he's walking closer to the school, right? So then your graph should look like this. It should be a straight line down, a slope of -1 because he's going 1 block per minute. Here's what C will look like. So he's got 12. He walked a constant rate of 1 block per minute 3 minutes later. So you should have it look like this. And then it was flat for 4 minutes because he talked with his friend. And then they ran to school at a constant rate of 2 blocks per minute. So we're going to go down. Wait, they talked for 4 minutes. I don't know why I'm having such a hard time with this one. All right, so then if it's 2 blocks per minute, that means he's going to get there about there. Pretty sure. He's going 9. Yeah. Okay, that's what your graph should look like for C. Then for D, he started walking to school at a constant rate of 1 block per minute. 2 minutes later, he realized he forgot his homework. So he goes 2 blocks in 2 minutes. So he ran back home. Zhup. And then it took him 4 minutes to find his homework. So he's at 7 minutes now. And then he was running late. So he ran a constant rate of 3 blocks per minute all the way to school. We're at 7. So he gets there in 4 minutes. So that's what his graph should look like there. If you notice, this was 2 blocks per minute. So that's a slope of -2, and this is 3 blocks per minute. So that's a slope of -3. So remember, you have to account for not just was he walking, but how fast was he going. Now, sometimes you may have it go where it just says they walked and then they ran. So it might help you to create some numbers for yourself so that you can create a flatter slope when they walk and then a steeper slope when they run. All right, thank you.